Oh, hi, everyone. Thanks for showing up for some more periodic practice problems. Here we have a pendulum. It's on a grandfather clock, swinging back and forth as it keeps time. The device is measuring the distance the pendulum is above the floor as it swings back and forth. The beginning of the measurement, the pendulum's at its highest point, 360 centimeters high. Exactly 1 second later, it was at its lowest point. 1 second later, it's back to its highest point. So let's go ahead and use this information to sketch ourselves some diagram of this sinusoidal movement. So here we go. Let's see. So 1 second later, so we know the period here, highest point, the beginning of the measurements is its highest point, 36. So how are we going to set our scale is our first question. We want our scale to go at least between 36 and 12. So we have a range of 24. I'm thinking 3 is good. So if we did, this is 12 high, this is 15, and then 18, and then 21, 24, 27, 30, 33, 36. Okay, that way our minimum is conveniently down there at 12, our maximum is at 36, and we can just visually see that the horizontal axis is 24. So go ahead and put your dotted line along 24 for the horizontal axis. The maximum there is at 36, and then the minimum is at 12. Okay, so let's go. We know that at the beginning it was at 36, so we're going to do seconds here by fours. Okay, so here is 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds. Why would I do that? I don't want the squiggly line to be so tight. I want to space it out so I can see more detail. All right, and so I know that it starts up there at the maximum. It swings down here to the minimum after exactly 1 second, and then it goes back up. It's going to be back up to the maximum after that much more time. So then we're just going to go along boop, 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 and boop. All right, and let's do it. Boom, try and hit that midpoint. Try and hit that midpoint. These are just sketches, of course. I'm just using the sketchy graph here to organize my thinking. And once we've got the graph done, then we can go ahead and create equations. Okay, so I noticed that cosine, it starts at its maximum, so cosine will not have a d transformation. Hooray! Okay, so here we go. A is equal to, the amplitude here is 12. I'm just looking visually at what we've got. K, well, the period is 2 seconds, so K is going to be equal to 180, because I happen to know that 360 divided by the period 2 equals 180. I'm very good at circles, and I know that 180 plus 180 is 360. Sorry, sometimes I just get a little sarcastic. And then C is 24. Okay. I really encourage you to find those connections, right? Like imagine someone turning around 180 degrees and then turning the other 180. Or maybe they do two cool tricks on their skateboard. The first one is a 180 and the next one is a 180 in the same direction. The skateboard is pointing its original direction. All right. Now, cosine has no d transformation. Why? Starting at its maximum. Great. We don't need to phase shift it left or right. Fantastic. So we would have height is a function of time, and it's equal to the amplitude, 12, cosine of 180x. Oh, sorry, I said time. It's t. So 180t plus 24. Okay, there's cosine. Let's do a sine one. H of t is equal to 12 sine also 180, but we're going to have a d transformation. Here is where I am rising and crossing the midline. It's exactly at 1.5. So t minus 1.5 plus 24. Done. Visually. I know that when I do the algebra, that's going to work. If you want to see me do the algebra, go look somewhere else. I'm not doing it again. All right. I also know that this was back here rising and crossing the midline at negative half a second. So another one would be 12 sine 180 t plus 0.5. And this would win style points because the d value is the smallest possible without using cosine. So then plus 24 still. Okay, so those would be correct, and super correct. All right, and that's how I would do that one. Any questions, hit me up by email. Bye.